Good afternoon. I'm Amrit, the co-founder and CEO of Indra Water. At Indra, we are pioneering decentralized wastewater treatment at the point of source and recovering this water for non-potable reuse applications. Our vision is to accelerate the transition to sustainable water management all across the globe. Now, before we move on to that, let us first look at on how centralized municipal systems have been functioning till date. Whenever we think about that, images of very large pipelines, large pumping stations, massive civil infrastructure flood our minds. We all know that all this wastewater from different buildings, different houses, multiple industries, they're all pumped to a single large infrastructure for treatment. But this process is inefficient, not only because there are energy losses, but we lose a lot of water because this infrastructure is difficult to maintain. It also becomes extremely difficult for an operator, even if a plant is completely automated, to react to changing wastewater requirements. Sometimes, before we realize that something is wrong with the plant, a huge volume of water has actually passed through without getting the right kind of treatment. Now, that is pollution happening right there. A huge amount of solid sludge is also generated by these plants, and most of the time, this sludge cannot be directly reused, as a lot of it is due to the industrial effluents that have come into the plant. Indra has been trying to solve a lot of these problems right from the word go. Our solution is compact and smart, and our solution is electrically driven. Our patented physioelectrical process is effective and efficient and performs coagulation, advanced oxidation, and disinfection of domestic and industrial effluents, and we recycle this water for non-potable reuse applications. Our systems are plug and play. Because we do not use any chemicals and we have eliminated the complete logistics chain associated with that, we're able to save 40 to 50% in operating costs and 35% or more on life cycle costs. Because our systems are electrically driven, our chemical processes or our electrochemical processes happen instantaneously, thereby dramatically reducing the retention time required in our systems. Hence, our systems are 75% lower in footprint. Now, that is a lot of productive area available for industries. It adds to economic viability of our projects. We recover 95% of the water that we treat. And this water is sometimes fit for direct use in industrial processes. We do not use any chemicals, and we are still able to meet all the Central Pollution Control Board norms laid down in India. Our systems are designed and built for mass production. Conventional systems generally take about 6 months to build and commission and about 2 more months to set right and stabilize the output. However, we are able to do this in 30 to 40 days even today. Our smallest systems are 5,000 liters per day, and our larger integrated modules are about 200,000 liters per day. And whenever we need to meet larger throughput requirements, we can stack up these modules and keep increasing the number. All our systems are automated and smart. We collect a lot of data in terms of water quality parameters and in terms of the functioning of the electrical equipment in our systems. This helps our systems to dynamically respond to changing water needs and in turn provide optimal water treatment, which helps us save money in the process. It also helps us achieve predictive maintenance and remote troubleshooting. We are primarily operational in the real estate market, that is sewage treatment in the domestic as well as commercial buildings. In textiles and dyes and paper and pulp, we're treating effluent water. And this is our primary target market in India. And this market is $4 billion in size, and it is growing at more than 15% year on year. That is a massive opportunity. We are egged on forward by the stricter regulations and mandates for setting up STPs and ATPs in the country. Rise in cost of fresh water and the huge gap between demand and supply is a massive opportunity for us. Even in the Southeast Asian market, the whole market is growing at 8.8% year on year. And less than 20% on an average of the wastewater generated is treated in our target segments in Singapore. Now that again is a great opportunity for us. As you can see from this graph, that we are very competitive with respect to all the other players in the market, and our 10-year life cycle cost for a sewage treatment plant has been displayed here. All values are in rupees per meter cube as observed in our projects in India. We are primarily operating in the sub 2 MLD category in the country. Some of the projects that I would like to mention are a 75,000 to 100,000 liters per day biorefinery plant that we set up, and we're able to recover almost all of the water for non-potable reuse applications as well as industrial processes. 50% cost reduction, 75% reduction in footprint, and 75% reduction in sludge has been achieved. We have also deployed plants in lakes for water reclamation for the purpose of irrigation, especially in the city of Hyderabad. In some of our textile projects, we have been able to reduce the cost by 50% and obtain 75% more water. And the water that we are supplying back at the source can be directly reused in the sensitive jeans washing process. All our activities have resulted in saving 200 million liters of water, and this number keeps rising. 500,000 people have been positively impacted by our actions. We have worked with a lot of large clients and partners, and we continue to work with the best in the industry to forward and to promote our technological prowess, as well as partner with them for improving our work. Imagine H2O has been instrumental in this process. Our team consists of myself, Krunal, Abhijit, Aditya, and Shriteja, and we have a lot of good experience from the likes of Amazon, Tata, Bosch, and we bring in all these expertise into quicker deployment of our solutions in the market. We were the recent recipients and we were the winners of the Urban Water Challenge at the World Water Week in Stockholm. And we have also won the Millennium Alliance Award very recently. Our plan for expansion in Southeast Asia involves partnerships and collaborations in technology, operations and maintenance, and also deployment of projects. We are also open to technology licensing because it is very important to understand that local solutions, local problems require the involvement of existing local players. And we believe that our technology can be improved with their feedback. So we are willing to work with all the players out there in the local market to efficiently deploy solutions that are more economically viable and help us make water recovery and wastewater treatment more sustainable in the long run. So I'm open to more questions. At the same time, before we move on to that, I would like to thank IPI for giving us this massive opportunity to showcase our work and help us become a part of this massive circular economy in the entirety of Southeast Asia. Thank you.
Next up, let's hear from Dr. Oriana Breger, CEO and founder of AquaCycle.
Hello, my name is Oriana Brecher. I'm the CEO and founder of AquaCycle. AquaCycle is headquartered in San Diego, California, and we provide technologies and services to treat some of the most challenging wastewaters generated in food and beverage production. Specifically, we address these ultra high strength wastewaters. So these are going to be wastewaters that only represent about 20% of the total volume out of the plant, but 80% of the cost relative to managing and disposing these wastewaters. Now, the concentrations of COD, or chemical oxygen demand, and TSS, total suspended solid, may be 100 times to 1,000 times more concentrated in organics than what you see in a typical city sewer. And so this poses challenges relative to disposal in that every client needs to meet their permit for whatever municipality that they're operating in. And they're going to be charged usually per kilogram of organic carbon and per kilogram of TSS that they put down the drain. These costs can add up anywhere from $1 million to $2 million per year per facility just to manage these very small volume, high concentrate waste streams. Now, if for whatever reason the company is not allowed to discharge to the sewer, the only other option right now is to haul these wastewaters off-site and land apply, which is costly and also has an environmental footprint. Now, these wastewaters are only going to be increasing as many companies are starting to decrease their overall water usage in production. That means the concentrates of wastewater coming out of the plant continue to go up and up. So this problem is only getting bigger. And that's where AquaCycle comes in. We provide an on-site wastewater treatment solution as a service to customers Usually we're saving them anywhere from 20 to 60% against surcharge costs and or land application costs. We validate the technology already in commercial environments with customers like Mars Wrigley and Anheuser-Busch. And we provide real-time remote monitoring and controls, which really helps to catch issues before they become problems and alleviate the requirement for a full-time 24/7 operator on site. We can catch anything before it becomes a problem and make sure that we call a local service provider to do whatever maintenance or emergency response may be required. That means minimizing any production shutdown for the client. Now, what I'm showing you here is a breakout of the actual product. And so what we offer is the bioelectrochemical treatment technology, or BET, which is that little black box that you see in the image. Now, each one of those reactors is about the size of a standard car battery. They're quite small. And we stack them together like Legos inside standard size shipping containers. They're a 20-foot or 40-foot container, depending on what the customer requires. The number of reactors that we have operating in hydraulic series, for example, 40, will define how much carbon we can remove in a given hydraulic residence time. And then we have multiple parallel treatment trains that will accommodate the volume at the customer site. Now, this is a bioelectrochemical process, and we use naturally existing bacteria already present in the wastewater and or sourced from the local environment to run the process. We bring these bacteria in with the wastewater that we want to treat, and they start to form biofilms or fixed films on the internal surfaces of each reactor, those little vertical cylinders that you see in the breakout there. Now the bacteria attach to those cylinders and they start using those surfaces as a way to breathe or a way to respire. And in that respiration process, they're giving up electrons. We harness those electrons, we move them across a circuit, producing DC power. Now, the faster we move electrons away from those bacteria, actually, the faster we're making them breathe. And when they're breathing fast, that means they're eating fast. And so the more electricity that we produce actually leads to faster treatment rates. Now, the power that we generate can actually be used to offset the power demand of our system. We aim for net neutral. In some cases, with high COD applications, we can be net positive. And so you see the picture here. That's actually an example of one of the systems we built for a small brewery here in Southern California. We have manufacturing established already in South Korea, Tijuana, and here in the United States. Here are some examples of some of the installations that we've done with various customers, both in the US, multiple states, as well as in Tijuana, Mexico. And some examples of data sets that we've generated. This is with a confection customer. You're looking in the bar chart there. The bars represent the percent of COD that we removed within a 4-hour hydraulic residence time. And the numbers reflect the total amount of COD that was removed in that hydraulic residence time. So we can actually remove up to 50,000 parts per million in 4 hours with only 12 BET reactors operating in hydraulic series. We're also generating useful power in this process. 1.6 kilowatt hours per kilogram of COD was recovered in this process, and that equated to around 22 kilowatt hours in a day, which is about 50% of the total power required to run the system, which was about the size of a Fiat in relative footprint. We also have some of the lowest secondary biomass production values relative to other technologies. Now, how we would stack up technology to technology in terms of full kilograms of COD removed per day. We offer some of the fastest treatment times on the market, the lowest secondary sludge production that you can see, as well as some of the best energy recovery efficiencies relative to conventional anaerobic treatment. And we're doing this in hours as opposed to days. And so we're very excited to work with our global clients, always seeking customers that are looking to solve issues with high sugar, high solids, and high surcharges wherever they're operating in the world. And we're always also seeking channel partners and local participants to provide that on-site service to our customers on a global scale. And we do have an A round open, so if you're interested to learn more, please do contact me. My information is there. And thank you very much.